All right. Now let's talk about the first type of sequences here. We have the list, and the list is a mutable. Okay, so mutable means when we make a change, we're not creating a new object, we're just changing the value stored in the same object. Okay, so to create a list, you just need to use square brackets to surround the elements of the sequence separated by commas. Now, this is not exactly the same concept as an array in Java. It's not the same concept because first it's dynamic, you can change the size. Second, it doesn't have to have the same type. You can have elements of different types within the same list. Okay, so you can see here this is int, string, boolean, and then another list or any other sequence. It doesn't matter the type of the element, it can be anything. Right? Now let's will give you the size. You can access any elements using the index. Now, if that element is a sequence in itself, then you can add another set of sequence, another set of, another index. Okay, but this part will be removed and replaced by this list, and then you're just trying to access that list like the element one in that list. All right. Now, if you try to go outside the range, you will be minimum. So there is no surprise there. Yes.
Can you explain doing one? Why did you get 5 and you go to or
yeah, okay, let's have a look. All right, so let's have a similar list here. Okay, so my list. Well, so the first element in the original list is 5. Okay, and then the second is a string ABC. There's a Boolean true, and then the last one is another list that happens to have also 5 in it. Okay, so let's say I want to access this 5. How do I read this 5? So the name of the list and then the index. What is the index of that element? 0. So the list starts, the indices starts at 0. Here in this list, it's not always the case, but in this particular context, the first element is accessed by the index 0. Okay. Now, what if we want to access this 5? So this 5 belongs to a list that it itself belongs to another list, right? So first we need to access that list. So how do we access it? What is the index of that list? 3. So 0, 1, 2, and then that's just 3. So that would give us access to that list itself. But I want an element inside of it. Okay, so I'm just gonna repeat that. It's exactly the same as saying another list. So I'm creating another variable. Okay, so now another list points to that list object. And then I can say another list. And how can I access the value of 5? Index 1. So this is 0 and 1. Okay. Now, so if I didn't have the variable, then I can use the index because the element in the list is in itself the reference. Okay, so I can do like this. It's exactly the same. Okay. Any other questions? Yes. That you want, yeah. So we know this list is the last element, right? So if you want to access from the back using the negative notation, it should be -1, right? Because it's length -1. So if you're accessing from the back, you're not using the 0, like the first. Okay. So it's pretty much saying here length of my list -1. So it's just shorthand, and you just remove this part. Okay, yeah.
So forward is from 0, 1 to 3. Backward is from -1 to 3.
Yes. Because this minus is just the shorthand of the operation that you subtract from the length. Okay.
Shouldn't the length of values be 4 minus 1 equal?
Yeah. Yeah, equal.
All right.
Yeah. Yes, my length 4 minus 1 is equal 3, which is the actual index.
Okay, so -1 automatically just separate the length.
Yeah. Okay, so if you say -1, you're behind the scene, you're actually saying length -1. Okay. All right.
If it doesn't have any, then it will produce error.
Yeah, it will just. So if I go out of range, so let's say we can only go up to 4 here. So we can say -4 because that is the result is 0, which is the first element. So we can say -4. Oh, sorry. Not the index. No, not the length, just -4 as the index. So that should be fine. If I go outside of that range, it would start giving me. Yeah. All right. So is there anything else you want to try out from this operations? Yes. ING. This one? So range. Okay.
No, second.
This one? Oh, okay. So let's say we want to know what is the index of value 5. Okay. Oh, it's not. Here it's follow my list. Dot index of value 5, which is true. Okay. Now let me just okay. Let's add try the append. So I'm gonna append some elements there just to make it list for longer. Okay, so plus equal is just the list itself plus what is coming. So I'm just gonna put a few 5s here. So 7, 8, 9, then another 5. Okay, so let's say 9 this. All right, so we've seen the first 5 is at index 0. Okay, now let's say I don't want this first 5. I want the 5 that is like I want to skip the first element. Okay, I want to start searching from value 1 from index 1. Okay, then I can say my list dot index. So here I want the value 5 starting from index 1. Okay, now let's see if I'm gonna find any. Now the index is 4, which is correct, right? Now what if I want skip this one too? So I can start searching from index 5. So by default, so the value 5, I want to start searching from index 5. Then the first value that it will meet is at index 9.
What if you want to find the one
The one what?
What if you want to find the one that's nested in the
So this is not visible at this level.
Oh.
No, I can search for the list itself.
But not.
Yeah. So let's say 3, 5. I didn't try this before, so let's see together how does it work. So I'm not gonna starting from 0. Yeah, so it did find it. But the 5 itself is not visible. I can search inside. I can when it comes, I can get access to the list itself and then search. Okay. Now, what if I wanna, let's say, so I'm searching for this, starting from index 0 and ending at index 2. So I shouldn't be able to find it. Wait. Most recent call is not in the list. Yeah, okay, so it didn't find it. So it didn't find it, okay? Because we stopped right before it. Okay? All right. Shall we move on? All right. So the next type of sequences we're talking about here is called the tuple. And the tuple is very much the same as the list, except that this one is immutable. Immutable. Which means that doesn't mean that we cannot change the values in it. We can, but when we make a change in a tuple, what happens is that a new object of tuple will be created, and then the variable will be pointing at it. Okay, so that's just the immutable version of the list. Now, why would there's no other difference than that between the list and the tuple? Why would we need two very similar sequences? For later on, when we talk about dictionaries, sometimes we need an immutable version of the object in order for, like, to enhance the performance and for other reasons. Okay, so whenever we need an immutable version of the list, we can turn it into a tuple, and we use the tuple. Okay, so why wouldn't we use a tuple to begin with? Now, if we're building the list dynamically or programmatically, it's better to not use the tuple during that build, because every time we make a change, a new object will be created, right? So you can, like, you're leaking the memory, and it's a bad performance, yeah. So if you are building the list dynamically, use a list, and once you're done, you want to turn it into a tuple to move on. Okay, so how do we define a tuple? Now we can use round parentheses, but the round parentheses are not essential. They are optional. What really defines a tuple is the existence of a comma. Okay, so if we need the parentheses are mandatory only when it's empty. Otherwise, how can we specify it as a tuple? All right. Other than that, we don't need a parentheses altogether. Okay, so there's no difference between T2 and T3. Okay, as long as you have the trailing comma, it would recognize it as a tuple. Here, if you try to print the type, it will say it's a tuple. But if you forget to put the comma, the trailing comma, even if you're using the round parentheses, it will not recognize it as a tuple. It's just whatever is inside. Okay, so if you print the type of the NT3, it will tell you now, because this is an int, it will tell you an int. Okay, it's only a tuple if it at least have a comma, it's one comma inside. All right. Other than that, it can contain any values. Could be a sequence, could be a list, could be another tuple, could be a string. Doesn't matter what's inside. Okay. It's just the entire. If you want to change the elements, the existence of the elements of the tuple itself, it will create a new object. But you can change the values inside if they are mutable. And we'll see that in that. Okay. Are you curious to see any of the operations on the tuple? Yes. So tell me what you want to say.